Welcome back to my YouTube channel. So we're going to do long division today. So what we're going to do is we're going to write out this first thing underneath the division line. So this is going to be x to the fourth plus 2x to the third minus 5x squared plus 3x minus 1. So you got to make sure that this is in standard form. Standard form being it's in descending exponent order. Okay? And then you're going to take what's out here, which is the divisor, and you're going to put it outside of the house. I'm not sure why we call it the house, because it's not a stable house. Anyways, so when you do long division, you're going to ask yourself, how many times does this go into this? Okay, or you're going to say x to the fourth divided by negative x squared. So if I ask myself that question, I'm going to get negative x squared. Okay, so you're essentially dividing what's on the outside by what's on the inside. Okay, and it's just that first term. But now you're going to multiply that term that you just got by everything on the outside. So negative x squared times negative x squared is going to give me x to the fourth. Negative x squared times negative 1 is going to give me negative x squared. And guys, when you write this out, you've got to make sure that your terms line up. So for instance, since this is negative x squared times 1, I would not put that below that x to the third, because otherwise it's going to mess me up when I subtract, right? Okay? I'm going to change the sign and draw the line. Thank you. Alright, so when I subtract, these are going to cancel out. I'm going to bring down this 2x to the third. And when I subtract these, I'm going to get negative 6x squared. I'm going to bring down the rest of this mess. Okay, so now what you're going to do is you're going to ask yourself, how many times does negative x squared go into 2x to the third? Okay, so 2x to the third divided by negative x squared is going to give me negative 2x. Okay, so I'm going to take negative 2x and multiply it times negative x squared, and that's going to give me 2x to the third power. I'm going to take negative 2x, multiply it times 1, and that's going to give me negative 2x. And again, remember, you're going to write that below the term that it corresponds to. So negative 2x times 1 is going to give me negative 2x right here. I'm going to draw the line and change my sign. So these will cancel out. I'm going to bring down this negative 6x squared. This will become plus 5x, because remember, we have that negative out here. Yeah? Okay, and then I'm going to repeat this process. It's very boring, right? Negative x squared goes into negative 6x squared negative 6 times. Negative 6 times negative x squared is going to give me this should be a plus. So this will give me 6x squared. 6 times 1 is going to give me positive 6. And then I'm going to change my sign, draw my line. This should be negative. Yeah, that's right. Okay, cool. All right, so I'm going to change my sign and draw my line. So this will cancel out. I'll bring down that 5x. And then negative 1 minus 6 is going to give me negative 7. Well, if I try to repeat this process one more time, I'm not going to be able to. So this is going to be my remainder, right? So I'm going to add on to this. I'm going to say plus 5x minus 7 over my divisor. Remember, my divisor is the stuff outside. So it's going to give me negative x squared plus 1. All right, so now we're going to synthetically divide. The reason why we're going to synthetically divide is actually it's going to help us find our zeros on this next problem that we're going to do. Not this problem, but the next one. So when we use synthetic division, what we're going to do is we're going to change the sign of the divisor. Okay, so this guy right here. Okay, so that will become a positive 2. We're going to isolate him in this little box. We're going to put him in the prison, right? Okay, and then we're going to list out our coefficients. Now, as you can see, it goes 4, 2, 1, 0, right? So I'm missing a 0x to the third, right? Yes? Yeah, we see that? Okay, so we've got to make sure that we write that out in standard form. Standard form includes all of those numbers that are not there. So this will be 1, 4, 0, -5, and -5. Okay, so we're writing out the leading coefficient or the coefficients of each term. Okay, so now we're going to bring down that first term. We're not going to do anything to it. We're just going to bring it down. And we're going to multiply 2 times 1 to give me 2. And then we're going to add these two things together. So that'll give us 6. The way I remember this is I multiply on the diagonal, add going straight down. So 2 times 6 is going to give me 12. 0 plus 12 is going to give me 12. 2 times 12 is going to give me 24. 24 plus -5 is going to give me 19. And 2 times 19 is going to give me, and -5 plus 36 is going to give me. Oh, wow. Wow. Y'all be trifling. This at the end is 38. -5 plus 36.
No, that's 38 to 36. 2 times 19.
Oh.
How do you not notice?
No, listen, it's Friday. Be like that sometimes. Okay, with me? All right, so now what we're going to do is we're going to take one less than this leading exponent. So that's going to give me x to the third plus 6x squared plus 12x plus 19 plus this remainder over my divisor. Now we're going to kind of put it all together with synthetic division and finding roots. Okay, so it says find all the roots for the following polynomial. Be sure to identify any roots, use synthetic division to verify the real roots, and find any imaginary roots. Okay, so the first thing you're going to notice is this graph, right? Okay, where do I have x-intercepts? I got one right here, -1, 0, and 2, right? Okay, do you notice how there's all these x's in all of these terms up here at the top in that equation? Yeah? Okay, so I'm going to divide everything by an x because that's real easy, right? Okay, so x to the 5th minus x to the 4th plus 2x to the 3rd minus 4x squared minus 8x. Okay, I'm going to divide all of that by x. So this is what that's going to look like. So I'm taking out an x from each term, right? Okay, the reason why I can do that is because look right here. You see where x is equal to 0 at the x-intercept? Well, we just pulled out an x. If we set that equal to 0, what is that going to give me? Exactly. So now what we're going to do is we're going to use synthetic division to create, almost like divide our equation down so that we can figure out what our imaginary roots are. So for instance, you see how we have this -1 right here? We're going to use that guy. So we're going to put him in the little box. And we're going to write out the leading coefficients of this equation. So that's going to give me 1, -1, 2, -4, and -8. -1's right here. Yeah. We did. We put it right here. We're going to use 2 later on. We're going to use 2 later on. Yeah, we're not there. All right, so we're going to bring down this first number. -1 times 1 is going to give me -1. -1 plus -1 is going to give me -2. -1 times -2 is going to give me +2. When I add those together, I get 4. -1 times 4 is going to give me -4. Add these together, I get -8. -1 times -8, +8. Look what happens. Oh my Lanta. Okay, so remember, we're going to make this one less exponent. So this will be x to the 3rd. This will be x squared plus 4x minus 8 with no remainder, which is exactly what your 0 should be. Okay? So now we're going to do it for our 2x intercept, right? Okay, so we're going to put 2 in the little box, and we're going to take these coefficients right here. Okay, so we're going to have 1, -2, 4, and -8. So we're going to bring down that first term, multiply these two, add these two, multiply, add, multiply. Look what happens. Yeah? And we're going to take one less exponent. Right? It's crazy. I said that for the last like 5 things. This is my favorite part. Okay, so now what you've got is this quadratic equation right here. Can we solve this guy? Yeah? Okay, so we're going to move that 4 to the other side. And we've got x squared equals -4. Well, now I'm going to take the square root of both sides. So what is that going to give me over here? Positive and negative 2i. Okay? So really quickly, what I want you to notice is that this was a 0, this was a 0, this was a 0, and these two things are zeros, right? So how many zeros do I have? 1, 2, 3, 4, 5. Look at what my exponent is. Yep, there's 2. There's 2 down here. Yep. Look at what my exponent is. Boom. Fundamental theorem of algebra. Remember AKS 54?
Nope.
Oh, okay. All right. So, last question. This is going to be on your performance final, obviously, as well as it's going to be on your unit 4 test. So, on number 1, it says, simplify the rational expressions. Okay, so the first thing that I want to do here is I want to factor. Okay, so if I factor this guy, I'm going to get a times c, which is 18, and I know you can't see that because I'm the worst.
Yeah.
Thanks, Mom. Okay. All right, so if I factor this guy right here, that's going to give me 18 in the top, -9 in the bottom. What 2 numbers will make that happen?
6 and 3.
Okay, -6 and -3. Wow. Okay, so this will be x minus 6 times x minus 3 up in the top. Okay, in the bottom, just because it doesn't have an exponent doesn't mean that you can't factor it. So what is the greatest common factor of 4 and 12?
4.
Okay, so if I pull out a 4, what am I left with? I'm left with x minus 3. Yeah. Okay, what do you notice is in the top and the bottom? X minus 3's. So my final answer is going to be x minus 6 over 4. And this is one thing that we need to talk about is extraneous solutions. If you canceled it out over here, that's an extraneous solution. Okay, so this is going to be x cannot equal 3. Here's the reason why. If you graph the original equation, there's going to be a hole. You know how we have error in the calculator? Yeah. It's going to say error, which means that this part is undefined. That's a hole in our graph. Okay, and we've got to include it. Cool?
Sure.
Oh, okay, cool. All right, I got a minute and a half. I got this. All right, so on number 2, we're going to multiply these expressions. Okay, so the first thing I'm going to do here is I'm going to factor. So what is my a times c? 64. What is my b? -16. Okay, so what 2 numbers will make that happen? -8 and -8. Okay, so this will be k, 1 over k minus 9 times k minus 8 times k minus 8 all over k minus 8. I feel like I'm saying the same thing over and over again. I know. All right, so we're going to cancel out 1 in the top, 1 in the bottom. Remember, trick-or-treating, you can only pick 1 piece of candy from the top, 1 piece of candy from the bottom. Okay? Yeah? Take the whole bowl. All right, so this will leave me with k minus 8 over k minus 9, where k cannot equal 9 because it's in the denominator, and 8 because we canceled it out. I'm going to take what's in the denominator, so this and this, and I'm going to multiply each fraction by it, and then I'm going to combine everything. And my next step would be to combine my like terms. So that's going to give me 2v squared plus 17b minus 10 over b plus 6 times v minus 2. I feel that. b cannot equal -6 and 2.